Today we'll discuss how to determine the deflection of pin-jointed plane truss by unit load method. We'll take one simple plane truss and we will find out what is the deflection at a point of a pin-jointed plane truss by unit load method. So already we have discussed that how to find out the deflection of pin-jointed plane truss by unit load method. So this is the formula delta. The deflection of the truss can be determined using this formula. Delta is equal to integration P dash E dV. Delta is the displacement at the point in the direction of unit load applied. P dash stress due to unit load and E is the strain due to applied load. Then in the case of pin-jointed plane truss or plane frame, there is only one type of stress, that is direct stress. This stress may be different in different members, but is constant at all points in a member. Already we have discussed in last class. Hence, integration P dash E dV is equal to summation of P dash E into AL, where summation is to cover all the members of the truss, and A is the cross-sectional area of the member, L is the length of the member, P dash the stresses due to unit load, K by A, K is the force in the member due to unit load, and E is the strain due to given load. Then you know this is the strain. The strain, this is due to the given loading system, is equal to P by A into 1 by E is equal to P by A, where P is the force in the member due to given loading. Then you can find out what is the displacement at a point in the direction of unit load using this formula. Delta is equal to summation of K by A into P by A into AL. Then the displacement at a point is equal to delta is equal to summation of PKL divided by A. The forces in the member of the truss is to be determined twice. Once with the given loading to get P terms, and second time with the unit load to get K terms. So you have to find out the forces in the member of the truss. Twice you have to take the analysis of the truss. Once with respect to the given loading, what is the load is you are given in the truss. By considering this load, you have to find out what is the forces in the member. Then you have to apply the unit load where the deflection is required. At that point, you have to apply the unit load, and by considering this unit load, you have to find out what are the forces in the member of the truss. So you have to take twice the analysis of the truss. Then after getting the forces in the member, this is the P, the forces in the member due to the external applied load system, and K is the forces in the member due to the unit load system. And you know what is the L and A and E, and then you can find out what is the deflection at a point in the truss. So already we discussed in last class, so this is sign convention. If the force in the member of the truss is tensile in nature, the arrow mark should be away from the joint. This is the arrow mark away from the joint. This is one joint, this is another joint, and here you see. So at this joint you have to give, this is the arrow mark for tensile nature, and at this joint you have to give, this is the arrow mark for tensile nature of the force. This is away from the joint. The arrow mark should be away from the joint. If the force in the member of the truss is compressive in nature, the arrow mark should be towards the joint. Here you see, this is towards the joint, this is joint, and this is the arrow mark, this is towards the joint. Here also this is joint, and the arrow mark is just towards the joint. So for compressive nature, so you have to give the arrow mark towards the joint. Then you take the tensile force is your positive and compressive force is negative. In the analysis, you have to use the tensile force is positive and compressive force is negative. Then in the analysis of each joint, use right arrow mark positive and left arrow mark negative. Here you see, this is your x-axis, this is y-axis, and here this is right arrow mark, this is right arrow mark, this is left arrow mark. So take right arrow mark is positive and left arrow mark is negative. Similarly, take here upward arrow mark is positive and downward arrow mark is negative. Similarly, you have to take for moment, that is the clockwise moment you have to take positive, and anti-clockwise moment you have to take negative. For moment you have to take, this is the sign convention. For clockwise moment you have to take positive, and for anti-clockwise moment you have to take negative. Procedure for calculating Truss deflection. So these are the steps. First, calculate the real forces in the member of the truss either by method of joints or method of section due to externally applied forces. You know the method of joints or by method of sections. So using this method of joints or method of section, you can find out what are the real forces in the member of the truss due to external applied forces. Then calculate the forces in the member of the truss. Consider the virtual load system so that only unit load is applied at the joint in the horizontal or in the vertical direction where the deflection is required. Then you have to find out by taking the unit load at the joint in the horizontal direction or in the vertical direction. For a horizontal deflection, you have to take the horizontal unit load, and for the vertical deflection, you have to take the vertical unit load. Then you have to find out what are the forces in the member, that you have to take K. So by considering the unit load, so you have to find out the forces in the member of the truss, that is you can denote by small k. Then you know what is the length of the truss member, so that is, you can find out from the geometry. Then you know the area of the truss member, this is given in the problem. And also you know what is the modulus of elasticity, this is also given in the problem. Then the displacement of the joint is calculated using this formula. Delta is equal to summation of PKL divided by A. So this is the procedure for calculating truss deflection. So these are the points you have to remember for calculating the truss deflection. Then coming to one example, calculate the vertical deflection components of joint B of the truss loaded as shown in figure by unit load method. The cross-sectional area of each member is given 500 into 10 to the power minus 6 meter square, and E is equal to 200 into 10 to the power 6 kilonewton by meter square. This is one simple plain truss, and one load is given at the point B, this is 20 kilonewton. Then you have to find out what is the deflection of joint B using the deflection formula and using the unit load method. So you have to find out what is the deflection at the joint B using the unit load method. So what you have to do? So by considering this external force, first you have to find out what are the forces in the member of the truss. First you have to find out what are the forces in the member due to this given load, due to the given load system. Then you have to find out the forces in the member by taking the unit load at the point B. You have to remove this load and you have to apply unit load at the point B. Then you have to find out what are the forces in the member of the truss. Then after getting this forces in the member due to the external applied force, then due to the unit applied load, then you can find out what is the deflection at the joint B. These are the steps to find out displacement in the truss. These are the different steps. So you can use for determination of displacement in the truss. So first you have to find out the reaction due to given loading. Then calculate the forces in the member due to given loading. Then find out the reactions due to unit load applied at B. Then calculate the forces in the member due to unit load at point B. Then find out the length of the truss members from the geometry. Then you know area and modulus of elasticity of the member. Then find out all the data in a tabular form. Then you can find out what is the deflection at point B. This is the formula. The vertical deflection at B is equal to delta B is equal to summation of PKL divided by A, where A is the cross-sectional area of the member, L is the length of the member, P is equal to force in the member due to given loading, A is equal to force in the member due to unit load, and E is the modulus of elasticity. And this is the formula. So using this formula, you can find out what is the vertical deflection at B. So what is the first step? So first you find out the reaction due to given loading. So first you find out reaction due to given loading, because this is the truss and this is the loading is given at B. Let us take the reaction at A and B is your VA and VC. At A the reaction is VA and at C the reaction is VC. Because here you see the truss loading and the geometry both are symmetrical, because this is the symmetrical truss and here the loading is present at the point B, symmetrical, just at the midpoint the load is present. So the loading and the geometry both are symmetrical. What is the reaction at both ends? What is the reaction at A and what is the reaction at C? The reaction at A is your VA and reaction at C is VC. So this is your equal to half of this load. VA is your equal to VC is equal to 20 by 2. This is your equal to 10 kilonewton. As the loading and the geometry both are symmetrical, the reaction at A and C is your VA is your equal to VC is your equal to half of this given load. This is your 20 by 2, so this is your 10 kilonewton. The reaction at A and C is your 10 kilonewton. Then find out forces in the member due to given loading. Here you got what is the reaction at end A and at end C. At support A, what is the reaction? And at support C, what is the reaction? VA, VC, you got here 10 kilonewton. Here you see, because you have to find out the forces in the member due to given loading. Due to what is the load is given, due to this load, you have to find out what are the forces in the member. So because here you got what is the reaction? VA. So VA you got 10 kilonewton. And when you are considering this joint, you will find out these two forces. Because this is the member AB, this is the member AB, and this is the member A. So you can find out what is the force in the member AB and what is the force in the member A. By taking the summation of vertical force is equal to 0 and summation of horizontal force is equal to 0, you can find out what is the force in these two members. Then after knowing these two, then what you have to do? You have to consider the equilibrium of joint E and you have to draw the free body diagram of joint E. First you have to draw the free body diagram of joint A. Then you have to take what are the forces acting at joint A, that you have to consider. Then you have to find out what is the force in the member AB and in the member A. Then you have to take the free body diagram of joint E. But at joint E, how many members meet here? So this is EA member, this is EB member, and this is ED member. So three members meet here, and the forces in this member. So these two are unknown. So this you can find out from the equilibrium equation. Summation of vertical force is equal to 0 and summation of horizontal force is equal to 0. So first you take the equilibrium of joint A. Forces in the member due to given loading. Take each joint and draw free body diagram, then find out the forces in the members. So first you take joint A. This is one reaction and this is one member and this is another member. So the force in the member AB, FAB, and the force in the member A is you take FAE. So here you take this is FAE, the force in the member, and in member AB you take the force is FAB. And this is the reaction at A. This is the reaction at A. This is the joint A. So first you assume, so what is the forces in the member? Because you don't know what is the force in this member AB and you don't know what is the force in the member A. So here you assume force in the member AB is your tensile and force in the member A is your compressive. And give the direction of the force. Then after solution, if you got the negative value, then you have to change the direction of the force. But if you are getting the positive value, then your assumed direction is your OK. So here you see this is the force in the member AB, and here you assumed this is your tensile nature, and the force in the member A is your FAE, and assumed the force in the member is your compressive nature. So compressive means the error mark is your towards the joint, and tensile means the error mark is your away from the joint. Then this is the reaction. Then you take the summation of vertical force is equal to and summation of horizontal force is equal to 0. So here you take summation of vertical force is equal to 0. So here you see this is vertical force, and you take the component of this force in the vertical direction. What is the component of this force in the vertical direction? This is the FAE is your acting at an angle of 60 degree. This is the member, and the force in the member A is your FAE, and this is your at an angle 60 degree. So you take the vertical component of this force. So this is 10 kilonewton upward, and this is FAE sin 60. This is your FAE sin 60. This is downward direction. So you know the upward arrow mark is your positive and downward arrow mark is your negative. So 10 minus FAE sin 60 is your equal to 0. Then 10 is your equal to FAE sin 60. 10 is your equal to FAE sin 60. Then FAE is your equal to 11.55 kilonewton, and here you got the value your positive. The assumed direction of the force is your OK, because here you have assumed the direction of the force is your compressive, and here you got the positive value. So this is your OK. So the FA is your equal to 11.55 kilonewton. Nature of the force is your compressive. Then you take the summation of horizontal force is your equal to 0. Here you see. So here this is one horizontal force, and you take the component of this force in the horizontal direction. So what is the component of this force in the horizontal direction? This is your FAE cos 60. This force, the component of this force along the horizontal direction is your FAE cos 60. So this is arrow mark is your right side, and this arrow mark is your left side. So FAB minus FAE cos 60 is your equal to 0. Then find out what is the force in the member AB. FAB is equal to 11.55 into cos 60 is equal to 5.78 kilonewton, and here also you got the positive value. FAB is equal to 5.78 kilonewton. So the assumed direction is your OK. So the FAB is equal to 5.78 kilonewton, and the nature of the force is your tensile. So both assumed direction is your OK. Then take joint E. So at joint E, how many forces are meet? 3 forces. This is one, this is one, this is one. Because but you know this force, because this is the member. This is these 3 members meet, but you know the force in the member A. You know. So take joint E. So here also you know this is, here you got this is your compressive force. The A force is your compressive force. That's why you give the direction of the arrow mark is your towards the joint. But you don't know these 2 forces. You don't know these 2 forces. So here also you have to assume this is your EB member, and this is ED member. Take the force in the member EB is your FEB, and take the force in the member ED is FED. Assume the force in the member EB is your tensile nature, and assume the force in the member ED compressive nature. This is your assume compressive, and this force you assume tensile. Then take the summation of vertical force is equal to 0. Summation of vertical force 0 means this is one inclined force. So what is the vertical component of this force? 11.55 into sin 60 and upward direction. And this is also one inclined force, and take the vertical component of this force. So FEB sin 60, and the direction is your downward direction. So take upward direction is your positive, and downward direction is negative. 11.55 sin 60 minus FEB sin 60 is equal to 0. This is the summation of vertical force. Then after simplification, FEB is equal to 11.55 kilonewton, and here also you got the positive value. So the nature of the force is your tensile nature. So assumed nature of the force is your OK. So FEB is equal to 11.55 kilonewton tensile nature. Then you take the summation of horizontal force is equal to 0. So here you see this is one horizontal force, and you take the component of this horizontal force, you take the component of this inclined force towards the right side the arrow mark, and the component of this inclined force is also right side arrow mark, but this horizontal force is your left side arrow mark. So take the right side arrow mark is your positive. So 11.55 cos 60 plus FEB cos 60 is equal to FED. That is 11.55 cos 60 plus 11.55 cos 60 minus FED is equal to 0. Then you find out what is the value of FED. Then you find out the value of FED is equal to 11.55 kilonewton, and you got here the positive value. So the assumed direction is your okay. So the nature of this force is your compressive. So here you got the force in the member AB, AE, ED, and EB. So you got this force, and what is the value of the force in member A? So the CD is also the same value. And what is the force in the member AB? So in BC member also the value is same. And what you got for the member EB and for BD is also the force is same. Symmetrical geometry of the truss and symmetrical loading. So the force in the other member also same. Give the arrow mark of the forces in the members of the complete truss. So force in the member due to applied load. So due to applied load, what you got the forces in the members and the nature of the force, just to show here, because here you got that AB, you got the tensile force 5.78 kilonewton, and for AE you got the compressive force 11.55 kilonewton, and for ED member, so here you got the compressive force 11.55 kilonewton. For ED you got the compressive force, this is 11.55 kilonewton, and for EB got the tensile force, this is 11.55 kilonewton. You got the forces in these four members. Then, so what is the force here? This is your compressive force, and here also the force is your compressive 11.55 kilonewton. And in the member AB, the force is your tensile 5.78 kilonewton, and in member BC, the force is also tensile nature, and the this is your 5.78 kilonewton. Similarly, in EB member, the force is tensile nature 11.55 kilonewton, and in BD member also the force is your 11.55 kilonewton, and the nature of the force is also tensile. So these are the forces in all the members of the truss. For complete truss, these are the forces in the member due to applied loading. What is your next step? You have to apply unit load here. You have to apply unit load at point B. Then by considering this unit load, you have to find out what is the reaction at both ends. Then you have to find out what are the forces in the member. This is the step. This is the process. So next you have to apply unit load at the point B. Apply unit load at the point B. Remove that 20 kilonewton load, and here you have to apply the unit load. Here you have to apply the unit load at point B, and due to this unit load, find out what is the reaction at A and what is the reaction at C. Because here this is also symmetrical, the loading is symmetrical, and the geometry is symmetrical. So due to this unit load at B, find out what is the reaction at A and find out what is the reaction at C. So what is the reaction at A and what is the reaction at C? So this is your 1 kilonewton. So the reaction at A is your half kilonewton, and reaction at C is your half kilonewton. Reaction due to unit load at B, at the truss and loading is symmetrical. VA is equal to VC is equal to half is equal to 0.5 kilonewton. So VA and VC both are equal, and that is equal to 1/2 is equal to 0.5 kilonewton. And find out what are the forces in the members of the truss. The force in the member due to unit loading, take each joint and draw the free body diagram, then find out the forces in the member due to unit loading. So first you take the joint A. Here also you take joint A because you know what is the reaction at A. Reaction at A is your 0.5 kilonewton, and you have to find out similarly. So what is the force in the member A and what is the force in the member AB due to the unit load at the joint B. So take here also assume the force in the member AB is your tensile and force in the member A is compressive nature, and take the summation of vertical force is equal to 0. This is vertical force, and this is also vertical force. You take the component of this inclined force vertical direction. So Fa sin 60 is equal to 0.5. Then Fa is equal to 0.578 kilonewton compressive nature. Here you got the positive value. The nature of the force is your compressive. The assumed direction of the force is your okay. So this is your compressive nature. Then you take the summation of horizontal force is equal to 0. So this is one force, horizontal force. This is horizontal force, and the arrow mark is your. You have assumed this nature of the force is your tensile, and this is the inclined force, and this is the arrow mark. So here this is right side arrow mark, this is your left side arrow mark. So here you take FAB minus FAE cos 60 is equal to 0. Then FAB is equal to 0.578 into cos 60 is equal to 0.289 kilonewton. And here also you got the value is your positive. So the assumed direction of the force is your okay. So the FAB is equal to 0.289 kilonewton, and the nature of the force is tensile. Then take joint E. Take joint E. So at joint E, here this one. So at joint E, how many forces are met? So this is one A member, and this is the B member, and this is the D member. So this member force is you know. The force in the member A is you know, but you have to find out the force in the member EB and force in the member ED due to this unit loading. Take this one. So here you know this is this one, but you don't know FED and FEB. So assume the nature of the force EB is your tensile and ED is compressive. This is compressive, this is tensile. Then take the summation of vertical force is equal to 0. This is vertical, the component of this inclined force vertical direction take, and this is vertical direction. So here this is your in vertical direction 0.578 sin 60, and here this is FEB sin 60. So 0.578 sin 60 minus FEB sin 60 is equal to 0. Then FEB is equal to 0.578 kilonewton tensile. Because here you got the positive value, and the nature of the force is your tensile. Then you take the summation of horizontal force is equal to 0 and find out the other unknown, FED. So here you see this is the horizontal force and this is the inclined force. This is inclined force. Take the component along the horizontal direction, and this is also one inclined force. Take the component in the horizontal direction. So FEB cos 60, and this is your 0.578 cos 60, and this is FED. The arrow mark is your left towards left, and these two arrow marks are towards right. So here 0.578 cos 60 plus 0.578 cos 60 minus FED is equal to 0. Then after simplification, FED is equal to 0.578 kilonewton. This is compressive nature. It got the positive value. So the nature of the force is your compressive nature. So assumed direction is your okay. Then just to write all the forces in the member due to unit load. Write the forces in all the members of the truss. Here you got this is your the compressive for A member. You got the compressive force. This is 0.578 kilonewton, and for AB member got tensile force. This is 0.289 kilonewton. This is away from the joint arrow mark. And here you see for ED member you got the compressive force 0.578 kilonewton, and this is the arrow mark. And for EB member got the tensile force, and here the arrow mark is your away from the joint 0.578 kilonewton. Similarly for other side take the same value. For if the A member is your compressive 5.578 kilonewton, then DC member is also 0.578 kilonewton and compressive nature. Similarly, if the member AB, this is your 0.289 kilonewton tensile force, and for this side also, BC member also, this is your tensile nature, and the force is your 0.289 kilonewton. Similarly, if the force in the member EB is your 0.578 kilonewton tensile, and the other side the BD, for BD member, the force is your tensile nature, and that is 0.578 kilonewton. So these are the forces in the members of the truss due to the unit loading. Here note arrow mark towards joint compressive force, arrow mark away from the joint tensile force. This is already I have explained. Then after getting the force in the member due to the applied force and due to the unit loading, then what you have to do? Then you have to find out all the data in a tabular form. So first you take what are the members. So first you take the member AB, BC, CD, DE, EA. Then this is your EB and this is DB. So take all the members here. Here you take the member AB, BC, CD, DE, AE, BE, BD. Then take the length of the member. Take the length in mm. So you know this is your 3 meter. AB is your 3 meter and BC is 3 meter. And this angle is your given 60 degree. So all angles are 60 degree. Length of all the members are 3 meter. This is 3 meter, 3000 millimeter. AB length 3000 mm. Similarly, BC, CD, so all length is your 3000 mm. Then area, the area in millimeter square, 500. The force in the member due to the external applied force. So this is for AB member 5.78. This is tensile nature, and for BC member 5.78 tensile nature, and for CD minus 11.55 compressive, for D minus 11.55 compressive, for A minus 11.55 compressive. These three. 11.55 compressive, this is 11.55 compressive, and this is also this is compressive, this is compressive, this is ED 11.55 kilonewton compressive, A 11.55 kilonewton compressive, and the CD also 11.55 kilonewton compressive. CD, D, and A. Then this one, this is your B, your plus 11.55. This is tensile, and BD is plus 11.55 kilonewton. This is tensile. Then this is the force in the members due to the unit loading at the point B. So this is 0.289 kilonewton for AB member, and for BC member the force is 0.289 positive tensile force, and for CD member the force is minus 0.578. This is compressive force, and for D member minus 0.578. This is also compressive force, and for A member minus 0.578. This is also compressive, and for B and BD this is positive tensile. B and BD. This is B and this is BD. This two is positive, this is tensile force. And these three force is your compressive, negative, and these two forces is also tensile, 0.289, 0.289. Then other forces are 0.578. Now, just to put all the forces due to the external loading and due to the unit applied load. What you got in the analysis, just to put in a tabular form. Then just to multiply here PKL by A, just to take this column, and here you write PKL. This is length you know, and this is the force due to the external applied force. This is the force due to the unit applied load. Then you take PKL by A. So here you multiply PKL and divided by A. Then you find out what is the value here. Find out what is the value here. So for all the members, find out the values. Then take the summation of PKL by A here. Just to add up all the this quantity PKL by A, just to add for all the members for the entire truss, just to find out the summation of PKL divided by A. So this is your equal to 20.319. Then after getting this one, then you can find out what is the deflection at the point B. So the vertical deflection of joint B is equal to delta B. So this is equal to summation of PKL divided by A. So you know what is the modulus of elasticity. This is given in the question, and here you got what is the value of PKL divided by A. So just to put here the values, you know delta B is equal to, you got here the summation of PKL by A is equal to 220.319. Then you put the value of modulus of elasticity and find out what is the deflection at the point B. So the deflection at the point B is equal to 1.1 millimeter. So this is the vertical deflection of the truss at the point B is equal to 1.1 millimeter. Using these steps, you can find out what is the vertical deflection of the pin jointed plain truss. Now all are clear that how to find out the deflection in a pin jointed plain truss.